eliminates the repetitive task of setting up and configuring development environments so that developers can focus on what really matters, that is building great software. Then DevOps engineer, so Docker streamlines software delivery, develop and deploy bug fixes and new features without any kind of roadblocks. And with Docker, we can even scale our applications in real time. So scaling meaning if I want two or three replicas of my application, it's just changing the number of replicas. Okay, then it is it matters or it affects both for startups and enterprise. Doesn't matter your organization is a startup or a very large enterprise, Docker is helpful in both the scenarios. Okay, now with this, lot of the time and resources devoted in developing, publishing, and hosting the product will get optimized here. Okay, now another advantage with Docker is, so Docker is all about speed. How fast can you deliver or develop your software? So it's about develop faster, build faster, test faster, deploy faster, update and recover faster. So in case of any failures also, and when we are using Docker, we don't have to wait. It's just a Docker run command which we have to execute. Clear? So now we'll get started with the background of Docker. Why do we need containers at all? So I had this requirement to set up an end-to-end application stack, including various different technologies, like a web server using Node.js and a database such as MongoDB, and a messaging system like Redis, and an orchestration tool like Ansible. So when we were setting it up, we had a lot of issues developing the application stack with all these different components. First of all, their compatibility with the underlying OS was an issue. We had to ensure that all these different services were compatible with the version of OS we were planning to use. There have been times when certain version of these services were not compatible with the OS that we were planning to use. And secondly, we had to check the compatibility between these services and libraries and dependencies on the OS. Okay, we have had issues where one service requires one version of a dependency and a library, whereas another service requires another version of the dependencies and libraries. So so that kind of becomes very difficult. And along with that, the architecture of our application changed over time. We had to upgrade to newer version of these components, such as like changing the database versions or changing the Node.js version or changing some of the libraries. And every time something changed, we had to go through the same process of checking compatibility between these various components and the underlying infrastructure. So components and the underlying infrastructure as well as the OS. The compatibility metric issue is which we had is usually referred to as the metrics from hell. Now this kind of becomes very difficult to manage if you have such a large application of, or if you're using such a diverse technology set. Now, in addition to that, every time we had a new developer on board, we found it really difficult to set up a new environment. The new developers had to follow a large set of instructions and run hundreds of commands to finally set up their own environment. Now, we had to make sure they were using the right operating system plus the right version of each of these components and components meaning libraries and dependencies. And each developer had to set all of them by themselves. Now, in addition to that, one developer may be using one OS and the others may be comfortable with another one. So let's say I am comfortable with Ubuntu, but what you are comfortable is with Red Hat. So we, as a developer, we can have different choices. So again, that becomes a problem. We cannot guarantee that the application that we are building would run the same way in different environment. In fact, among the developers also, it's not certain that it will work in the same way. So all of this made our life in developing, building, and shipping the application really difficult. So I needed something that could help us with the compatibility issue and something that will allow us to modify or change these components without affecting the other component and even modifying the underlying operating system if required. And then the search landed in Docker. So with Docker, I was able to run each component in a separate container with its own libraries and dependencies. Okay, and this was all on the same VM and the OS, but within separate environments or containers. We just had to build the Docker configuration once, and all our developers could now get started with a simple Docker run command, irrespective of the what underlying operating system they run. So to run my different web server database messaging and orchestration tool, all they needed was to make sure Docker is installed on their operating system. Okay. So that's the kind of background why is Docker important and how is it helpful. Okay, now we've been talking about Docker and containers a lot. Now let's look at what these are actually. So containers are actually completely isolated environment, as in they can have their own processes, their own networks, and their own mounts. Mounts meaning the virtual disk. Okay, it is similar to that, similar to the virtual machine, except that in virtual machine they don't share the same OS kernel, whereas in container the containers share the same OS kernel which my hardware is using. Okay, so now let's try to revisit some of the basics concept about the operating system. So if you look at the operating system like Ubuntu, Fedora, SUSE, or CentOS, they all consist of two things. One is the OS kernel. So OS kernel is responsible for interacting with the underlying hardware. The OS kernel remains the same for all these operating, which is Linux in this case. Okay. Now here, the second component is software. So in this case, it's above the operating OS kernel that makes the operating system different. So the software may consist of different user interface, drivers, compilers, file managers, and developer tools. So you have a common Linux kernel shared across all OSs and some custom software that differentiate the operating system from each other. In fact, in the Unix session also you have gone through this, that all of these Unix operating system or Linux operating system shares the same OS kernel, which is Linux. Okay, now having said that, so we said that Docker containers share the underlying kernel. So what does it actually mean? So let's say we have a system with Ubuntu OS. So my Ubuntu OS is installed in one of my laptop, let's say, and we have Docker installed on it, and we are running Docker on it. So we can run any flavor of OS on top of it as long as they are all based on the same OS kernel. So in this case, it is Linux. If the underlying OS is Ubuntu, Docker can run a container based on another distributions. So it can be Ubuntu, Debian, or Fedora, SUSE, or CentOS. Now, each Docker container only has an additional software that we just spoke about in the previous slide. So that makes the operating system different. And here in this case, Docker utilizes the underlying kernel of our Docker host, which in this case is Linux, and we are having Ubuntu. So what do you think, what OS is there which will not share the same OS kernel? Or which operating system do you think we cannot use it here to run our Docker containers?
Windows.
Windows, right? So Windows we cannot run because Windows has its own OS kernel, and also the Mac. Now, so you won't be able to run a Windows-based container on a Docker host with Linux on it. For that, you will require Docker on Windows Server. Okay, so that's the concept over here. But there a confusion comes when you install Docker on Windows and run a container based off Linux. So you may say that when you run a Docker container and try to create Ubuntu container, let's say, the Ubuntu container will get created. Okay, but when you run Docker on Windows, you're not actually running Ubuntu container on top of Windows. So what Docker for Windows does is it creates a Linux virtual machine uh, under the hood. And when you run the Docker run Ubuntu command, so it actually runs Ubuntu container on a Linux virtual machine. Okay, so that's the misconception here when you run Docker on Windows. But definitely, when you're running Linux containers, you will not be able to run the Windows operating system on the Linux kernel. Okay, so here you might ask, isn't that a disadvantage? So the answer to that is no, because unlike hypervisor or virtual machine, Docker is not meant to virtualize and run different operating systems and kernels on the same hardware. The main purpose of Docker is to package and containerize application and to ship them and to run them anywhere and anytime and as many times as you want. Okay, so virtual machine has a different purpose to virtualize your hardware, whereas Docker has a different purpose to containerize your application. Now that brings us to a question, which is difference between virtual machine and the containers. So now let's talk about the difference between containers and the virtual machine. As you can see on the right side, in case of Docker, we have the underlying hardware infrastructure and then the OS. And on top of it, we have Docker. Docker then manages the container that run with the libraries and dependencies along with it. In case of virtual machine, we have a hypervisor. So we have a hardware And we have a hypervisor like EXS or Hyper-V or Oracle VirtualBox. And then we have the virtual machines on top of that created. As you can see, virtual machine has its own OS inside it, then the dependencies, and then the application. So as a result, the overhead of having its own operating system with the virtual machine causes higher utilization of underlying resources, as there are multiple virtual operating system and the kernel which is running. So now in this case, as you can see, we have different OSs here, right? But in Docker, we have only one OS, and my container is using this OS kernel. Okay, now as a result of which the virtual machine also consumes higher disk space, as each VM is heavy and is usually in gigabytes in size, whereas containers are very lightweight and are usually in megabytes. Okay, so now what we are telling here is when you install Windows on laptop or desktop, right? You see some of the space goes on to the operating system files. So that's what we are talking about here. All the operating system files and the kernels get stored here when you create a virtual machine. Whereas in container, you don't have to do that much. Okay. Now, when you're booting up the virtual machine, so a set of processes needs to be made active when you're booting a virtual machine. Whereas in Docker, it's only one process that you need to boot up or you need to start. So the boot up time here is very high compared to the boot up time in the container, which is very less here. Okay, so that's the difference between the virtual machine and the containers or Dockers. Now, it is also important to note that Docker has less isolation as more resources are shared between the containers, like the kernel, whereas VMs have complete isolation from each other, since VM does not really depend on the underlying operating system or the kernel. So in terms of isolation, you don't get it here, but in virtual machine, you get the complete isolation. Okay, so now any doubts on difference between the virtual machine and the containers? Okay. Now, to give you one more difference here, now I have this hypervisor, and this is a hardware. On the left side, this is a virtualized environment. On the right hand side, it is a Dockerized environment. So here, as you can see, I have the Linux operating system kernel. So in this, I can run only Linux containers. Now here, I can create virtual machine with any of the operating systems. So this can be Linux operating system, whereas this virtual machine can be Windows operating system. So that's one advantage of using virtual machine. Now, having said that, it's not an either container or a virtual machine situation. It's both container and virtual machine. So now when you have a large environment with thousands of application containers running on thousands of Docker hosts, you will often see containers provisioned on a virtual Docker host. So that way we can utilize the advantage of both technologies. We can use the benefits of virtualization to easily provision, decommission the Docker host as and when needed. And at the same time, we can utilize the benefits of Docker by easily provisioning applications and quickly scaling them if required. Okay, but remember, when we use Docker and virtual machine both, the number of virtual machine which gets utilized becomes less, as the containers are using very less CPU's memory and disk space. So is this clear? Any doubts on the virtual machine and Dockers?
Sir, I had one question. Can we say that
Yeah.
virtual machines can be more secure because since they run in isolations? About the security, so can the VMs be more secure than the containers?
Madhur, your voice is breaking.
Is it all right now? Hello.
Slightly better. Hello.
Yeah. So I was
Yeah,
yeah. So I
slightly
was
better.
saying. So I was saying, can the VMs can be said to be more secure than the containers because they run in isolation? Or talking about security, are containers more secure?
Okay, so the question is containers more secure or the virtual machine more secure, right?
Yes, right.
Okay, so now since VMs are running on the isolation does not mean VMs are more secure. So isolation meaning they can have their own processes, they can have their own operating system, kernel, libraries, and dependencies. So that's the only difference. It does not matter much about the security. Now, how security comes here is, uh, let's say you want to host two applications for two different clients. Okay, so you're supporting two different clients and you want to host the applications of both of them. Now, if you host both the application on one Docker host, and if you have to give your client access to that Docker host, then he will gain access to his instance of the application as well as the other instance of the application, which is of the other client. Whereas if you are hosting that in two different virtual machine, then you get two different credentials, user IDs, and password for that, right? So separately you can share with both the clients. Mm, Getting it? So in operating system,
Yeah.
when you have a set of software that makes it different, so that comes with its own advantages and isolation. It's not about having more security if you're running only one client or one tenant for the application as such. Clear?
Yeah. Yeah.
Okay, so any other doubts between the virtual machine and Docker?
Sir,
Yeah.
can't we install like Docker on Windows and then use it for our usage when we use Jenkins and other thing? Can't we use Docker for Windows? There should be desktop application for it as well.
Yes, you can install Docker in Windows as well and
But
create
yes, sir.
Docker containers for Jenkins and all.
So the same application that you showed yesterday by running commands in Linux, and we can do that the same thing by using the desktop application as well.
Using the desktop application as in?
Can we use a desktop application for using with Jenkins and all those other things that we did yesterday?
Um,
Like in short,
you
my
mean
question is like, can we use desktop application Docker for all these things, for all the computation that we are doing? Can we use that desktop Docker?
Okay, so Docker only provides you the capability to run application on top of it. So it can be any application. Until unless it is Dockerized, you will be able to run it. Now, we created a Sonar Cube server with Docker yesterday, right? So in
Yes,
a
sir.
similar way, you can also create a Jenkins server with Docker. And
Okay.
this, either Jenkins or Sonar, you can do it in Windows or Linux host. Okay, so Docker
Okay.
supports both Windows and Linux and also the Mac operating system. But
Okay,
the
sir.
only requirement is the virtualization should be enabled at the BIOS level. Now,
Yes, sir.
the reason why we are not running Docker on Windows in your system is it is BIOS is at the BIOS level, the virtualization is disabled. And as a policy in Amadeus, you cannot enable the BIOS virtualization. Okay.
Okay.
So that's why we are running it on Linux operating system.
Oops.
Okay. Now we will also run Jenkins with Docker, and we will see some of the commands, and we'll make it more clear. We can revisit on this concept if you want to. Okay. So now we've spoken about lot of theory, but how is this done? So there are a lot of containerized versions of applications which are readily available as of today, as most of the organization have their products containerized and available in the public Docker registry, which we call as Docker Hub. For example, you can find images of the most common operating systems, databases, and other services and tools like Redis, Node.js, and all. Now, once you've identified the image that you need to install or run, you can install Docker on your host. Bringing up an application is very easy here. So to create an Ansible container, or to run an Ansible container, I simply run the Docker run Ansible command. Now, to create a MongoDB container, I just run a Docker run MongoDB command. Now, similarly, for Redis, I run Docker run Redis, and for Node.js, I run Docker run Node.js. Now, if you need to run multiple instances of the web service, simply add as many instances as you want. So you see here, I run Docker run Node.js 3 times. It created 3 Node.js container, which is hosting my web application. Okay. Now, in case one of the instances has to fail, suppose this one failed, we can simply destroy this container and rerun the Docker run command. Okay. So that's the advantages of using Docker. Now there are other solutions which are available for handling such failures, which is our orchestration tools like Docker Swarm and Kubernetes. We are going to talk about that as well day after tomorrow. Clear? Now we have been talking about the images and containers, right? Let's understand the difference between the image and the container. So image, Docker image is a package or a template, just like the VM template or ISO file. Okay, it is used to create one or more containers. So from one of my Docker image, I can create any container, right? So in VMs, you get the ISO file, right? Initially, when we were starting this DevOps training, you were told to create a Ubuntu virtual machine, correct? Then an ISO file was shared with all of you. So that was with respect to virtual machine. Similar to that, we have the Docker image. Now, containers are running instances of those images that are isolated and have their own environment and set of processes. Okay, so now, as we have seen before, a lot of products like Ansible, Node.js, or Redis, these products have been Dockerized in the Docker Hub already. In case you do not find that what you're looking for, you can create your own Docker image and push it to Docker Hub registry. So for example, let's say I wanted to run SonarQube. So what I did was I ran the Docker run SonarQube command and I had my SonarQube server up and running, right? But when we wanted to run HappyTrip, we had to go through a lot of process, right? So HappyTrip is an application which we want to Dockerize or containerize. So in that case, we can create image of our HappyTrip application and push it to the Docker registry. And then later create containers from the HappyTrip image and use it. Clear? So now coming back to the next topic. So container advantage again. Now traditionally developers developed the application and then they handed over to the operations team to deploy and manage to the production environment. Now they when they hand over the application, they also provide a set of instructions such as information about how the host must be set up, what prerequisites are to be installed on the host, or how dependencies needs to be configured, or it can be even how database connections needs to be established. Now, since the ops team did not really develop the application on their own, they struggle with setting it up when they hit an issue. Now, when they hit an issue, they work with the developers to resolve this particular issue. This is about the traditional approach. Now, here with Docker, the developers and operations team work hand in hand to transform the guide into a Docker file. Okay, so here what we are seeing is app.war and the guide on how to install this application or deploy this application is converted into a Docker file. Now, this Docker file is actually your Docker image, you can say, with, and this will host both the application.war and set of instruction to be executed. Now, this Docker file is then used to create images for their applications. Now, this image, they hand it over to the operations team. Now, the image can now run on any host with Docker installed on it, and it is guaranteed that it will run the same way everywhere. So in be it any operating system or any virtual machine, it will run the same way. So the ops team can now simply use the image to deploy the application since the image was already working when our developer built it, and operation does not have to modify it. It continues to work the same way when deployed in production as well, right? So that's one example of how a tool like Docker contributes to the DevOps culture. So here in this case, dev and ops both writing the code and building this image. Okay, so this is another advantage with container. Clear about this? Okay. So now moving on to setting up Docker. So I hope all of you have the Docker setup done, right? Anyone not having the Docker setup? Okay, so we can skip this part. It is more or less the same thing. Okay, so now this is one thing. As I said here, to avoid typing sudo every time, you can type sudo usermod -ag docker and then $user. So did it work yesterday or no?
No, it didn't work.
Okay, so we can try doing it now, or else we can just simply use sudo for the moment. Now, the additional command which is here is to check the version of Docker which is installed on your system. You can use Docker version here. Okay, so all of you open the Linux virtual machine and type Docker version. You will get to see what version of Docker is installed in your system. Okay, so which version is installed?
19.03.12.
Yes, yeah.
19.0. Okay, so just one command. Basically, you may be asked to check the Docker version and you need to update Docker sometimes. So that's how you can check, and you can always check the uh, Docker website to see what is the latest version which is running. Now, to see the Docker configuration, you can execute this command docker info.
While executing Docker info, I'm getting this client debug mode false and server error, got permission denied while trying to connect to Docker daemon socket.
Yes, I'm also getting the same error.
Okay, try with a sudo.
For me, it's running.
Okay, try with a sudo for whom it is not running.
Yeah, now with sudo it's working.
Yes.
Okay. Okay. Now, so next thing which we are going to do is we are going to run a Docker container. Okay. So now I'll just show you the Docker Hub. So you can access the Docker Hub at hub.docker.com. So it looks like this. Okay, now I have some images in my Docker Hub, which is showing here. Now, in this Docker Hub, we can find out the images that we want to use. So let me first show you the Sonar Cube image. Okay, so this is my Sonar Cube. Okay, so when you want to run or use any image, so first see, is it a Docker official image or not? Okay, so that confirms the authenticity of the Docker image that you're trying to use. Okay, now here, as you can see, there are different versions of SonarQube which is available. Now, you can just see some of the quick references on how to set this up and how to get it running. Okay, but for now we are just going to get started with some of the basic images. Okay, this is just for giving an example. Now I made a Docker run command yesterday and gave it to all of you to run the SonarQube. Okay. Okay. So here now I'm going to search the image whalesay. Okay. Now before that, if you run in any of the tags which is available, let's say this. So this is 7.9.4 and this is a long LTS release. LTS release similar to what we have seen in Jenkins. You will get to the Docker file. This is how your Docker file looks like. And this basically has a set of commands which makes the SonarQube server up and running. We will come to the Docker file as well and how do you create a specific Docker file. So now, let's say search one image, which is whalesay. Okay, so this is from Docker, just to verify if Docker is perfectly installed or no. This can be used. Okay, so now let me give me a moment. I'll just turn on the Ubuntu virtual machine. Okay, in the meantime, you can just run a container with whalesay image. So to run a Docker container, you use the Docker run command. Now I'm going to say this as a command: Docker run Docker / whalesay cowsay hello Prabha. Now here, if you go to Docker Hub, you will see what does it mean. So here it says how to use this image. When you run this command, Docker run Docker whalesay cowsay and then boop. So it creates a Docker container and prints this in the console where this is the text which it prints. So now I'm also going to run this container and we'll see what happens. Okay, just a moment. Okay, now you can run this image. You can run this command in your Docker host. Okay, so I'm going to refer to this term a lot, which is your Docker host and Docker container. So wherever you installed Docker software, that will be referred to as Docker host. Okay, which in your case is your Red Hat machine. Okay, so now I've also logged into my Docker host. And here I'm running this command. Okay, so it is running. Now you see it says unable to find image locally, and it downloads from the internet. From the internet, when I say it downloads from the Docker Hub. Okay, so is it running for you guys?
Yes.
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 Okay, okay, fine. So now it's running and we have verified our Docker setup. In fact, yesterday itself we did the verification. This is the first container we wanted to run. Now I'm going to start with the Docker commands now.
Sir, I had one doubt. Like yesterday, we created the SonarQube container, but even like after closing my VM, the application was the SonarQube was still hosted at that port. So, uh, how does that work? Like,
Okay, so I'll tell you that how does it work. Okay, so this is the uh, terminal which I'm using to connect to my Linux server, as you can see here. Okay, now I have this virtual box, Oracle virtual box, in which my Ubuntu virtual machine is running. Okay, and this is the actual Ubuntu virtual machine. Okay, now here as you can see, I have the IP address 192.168.0.106. Clear? Now, even if I disconnect this terminal, this is only a terminal which is used to connect to my virtual machine. This is not actually the real virtual machine. So if I disconnect this and I go here, I still see that Ubuntu is running. But when I try to close this virtual machine, it says me, do you want to power off the virtual machine or save the session state? Okay. So when I close my virtual machine, then I won't be able to access it.
okay, now
Okay.
got it.
So at the
So,
backend, MADS is hosting the virtual machine, which is available 24/7 or which is running 24/7.
got it.
Okay. So now we'll get started with the Docker basic commands. So here, okay. Now to get the complete list of Docker commands, you can simply type, sorry, so you can simply type Docker in your Docker host. That will give you all the Docker commands which is available. So I type Docker and this will basically list all the commands which is available for running in Docker. Okay, now talking about the basic command format in Docker, it is Docker command and then subcommands and then some of the options. So talking about the container and run command. So within container, you have a run as a subcommand, and what image or what container you want to run, you provide that as option, which is Nginx in this case. Similarly, for volume, it is Docker volume. I'm using inspect as a command, subcommand here, and I'm inspecting this volume. This is name of my volume. Okay, we'll run Docker. We'll see some Docker run and volume commands. Don't worry about it much now. But to give you a syntax, this is the syntax: Docker command, then subcommand, and then some of the option. Okay. Now, if you need help with any of the Docker commands, so simply type Docker container, then -help. This will basically tell you what all are the subcommands. So suppose if I want to have run, now I can say Docker container run and then help. Now this will tell you what all options do I get to provide in this. Okay, now moving on to Docker Hub. So we have already seen Docker Hub a bit, and in the later slides, we are going to create a Docker Hub account as well, where we can push our custom images. Okay, now we'll see some of the features of Docker Hub, and see, so image repository. Now Docker Hub stores the image repositories. We can find and pull images from community and official images, and we can also manage push and pull from our private image libraries, to which only we can have access if we create a private image repository. Next is automated builds. So automatically create new images when you make changes to the source code. So this happens when you integrate your Docker and GitHub, then you can automatically create new images. Then webhooks, feature of automated builds. Webhooks lets you trigger actions after a successful push to the registry. Now, then you have organization. We can create work groups to manage access to our image repository. Now, these are some advanced Docker Hub features, organization, webhook, automated builds and all, but it's worth to have the knowledge about it. Now, GitHub and Bitbucket integration, as I told you, add the hub and your Docker images to your current workflow. So GitHub and Docker Hub, you can integrate it very easily. Now, let's say I want to run an Nginx image. So, or Nginx container. Suppose if I want to run an Nginx container. So what I can do is I can go to my Docker Hub and search Nginx. Now, by the way, Nginx is a web server that we use to host the application. Now, here you see you get different images with respect to Nginx. Now, but this is the official image. Now, this is by Nginx, but others you see, those are not the authenticated or trusted images. So you should always look for the official image of any of the software first. Now, as you can see, you will see different commands to run Nginx here. Okay, so this is one way you can search for the Nginx image, or else another way of searching for the image is also from the CLI or from your terminal. So within my Docker host itself, I can type command docker search Nginx. Okay. I'll get into sudo. Okay, so this is the docker search command. Now by default it checks in the Docker Hub registry, and here also you get some of the things like that. Is this official? Yes, it is the official build of Nginx. Okay, now to run the Nginx container, we type this command docker run Nginx. Okay, so let's type this command docker run Nginx and see what happens. So I'm going to type docker run Nginx. Now this says unable to find the image Nginx latest locally. So it is downloading from my Docker Hub. So in the background, it downloads image from the Docker Hub and after the download is finished, it starts a new container from that image. Okay, so we'll just see that here. Now download is complete. And you see that my Nginx container is running. Okay, now we'll see some more commands. To list the running containers, we type this command, which is docker ps. Okay, now I'm in my terminal now. Okay, so when I run docker run nginx command, it by default runs in the foreground. So I am within my nginx container. And if I have to get out of this, I need to type, I need to hit Control C. But let me do one more thing. I'll open up one more terminal, and I'm opening the same terminal. Sorry, a different terminal for the same server. Now I'm again executing sudo. Now here, if I type docker ps, I see my nginx container is running. Okay. If I do a Control C here, okay, in my nginx, where I executed docker run nginx command, if I put Control C, I will get out of that nginx container. Now, when I do that, and if I type docker ps once again, you see there is no containers running over here. Okay, because containers, as I mentioned, they are only meant to host or to maintain a specific process. So Nginx was the process, or Nginx web server was the process which was running, and we exited from that, and the container also died. Okay. Now to see the
Sir?
Yeah.
I was not able to get the Nginx image. Like it says error response from daemon pull access denied for Nginx.
Okay. Anybody else getting the same issue? So Rayam, can you try with a sudo command?
Yeah, I already tried with sudo.
You're already in sudo. Okay. We'll just have a look. Okay. But you were able to execute Sonar Cube, right?
Yeah, I was able to execute Sonar.
Okay. Just check the spelling of Nginx. Is it correct or no?
Yeah. Oh, okay. Sorry.
Okay. Okay. So I was telling the containers we exited from the container. Now, when I type docker ps, I do not see the container. Now, to see the list of all stopped containers, what I can type is docker ps -a. Okay, so this will list all the containers running and stopped both. Now I see this, so I have a couple of containers. Here is my Nginx container, which exited 3 minutes ago. Okay, let me clear this and execute it once again. Okay, so here is my Nginx container, which exited 2 minutes ago. Okay, now this way you can see the list of all containers running as well as the exited. Okay, so now moving on to the next commands. So to stop a running container, I can type docker stop, then the container ID. And to remove a container, I can type docker rm, then the container ID. So what do I mean by this is, I have two terminals open. In both of them, I'm connecting to the same server. Now let me clear both the terminals. Okay, so here what I want to do is I will run the docker run nginx command once again. Now here, see this, when I run docker run nginx command, it immediately started. So the docker image of nginx got downloaded only once. Now, if I do a control C, the container will get stopped. But if I'm in another terminal, I see this nginx container is running. Now, here with the container, you can see multiple things here. When you see, say, docker ps, every container or everything what you create in Docker gets a ID. So container gets a container ID, volume will get a volume ID, network will get a network ID. Now here you can see some more informations like what is the status, is it up, running or no, what is the port on which it is running. Okay. Now to stop this container, I can type the command docker stop and then either my container ID or the name of my container. So nice underscore surf is the name of my container. It is a random name which Docker provides you. So when I do a Docker stop and then the container ID, here you can see I got out of my Docker container. Okay. But if I do a Docker ps-a, I still see both of my containers, nginx container. Now, if I want to remove this, I can type the command docker rm. If I don't want this to occupy space in my Docker host, I can type docker rm and then the container ID. Now, if I type docker ps-a, I see only one container, whereas here I see two containers. Okay. Now, another thing is talking about the images now. So, if you remember when we downloaded nginx or Whalesay, it downloaded the image first. But how do we see the list of images? So to see the list of images, we can type docker images. Okay. So when I say docker images, it gives me the list of image which is available in my system. Now, as you can see, each of the Docker image is having a size of the image. Now, so my Docker Whalesay is consuming, let's say, 247 MB, and I do not want to waste my this size in keeping the Docker Whalesay image because this is of no use for me in the future. So to remove the image, what I can do is I can remove it with this command docker rmi and then the name of the image. Okay, so let's try removing the Docker Whalesay. Whalesay is not something which we are going to use later, so you can remove this instead of nginx. So I type docker rmi and then docker Whalesay. Now, when I do this, it says me error response from daemon. unable to remove repository docker whale say because this container. So container and this container ID is using this image. So what I can do is I can remove this container first. So Docker will by default stop you to accidentally remove some of the images if any container is running. So I'll remove the container first and then I will remove the image. So I remove the container here now and I'm now removing the Docker image. Now you see it is deleted. If I again execute Docker images command, I will not see the Docker image over here. Okay. Clear? These commands are clear? Okay, so now let's look at some more commands. Suppose I have a need to pull the image and I do not want to run any of the container at this moment. So I can just pull an image and run that image at a later point of time. To pull an image, we can type the command docker pull and then the image name. So Ubuntu is the image that we are going to use at a later time. So all of you can do a docker pull Ubuntu. So let's execute this command.
Sir, like once we have stopped the container, how to restart it? Like Docker start or Docker run?
Docker restart you can type. Docker restart and the container ID.
Okay.
Okay. So now is the image pulled, the Ubuntu image?
Yes.
Okay. So now quick question, to run the Ubuntu container, what command do we type?
Docker run.
Docker run then
Image name.
Ubuntu, right? So to run the Docker, to run the Ubuntu container, I type docker run Ubuntu. Okay. So now I did run a Docker container from the Ubuntu image. Okay. Now it is running. Now the container has been successfully initialized and it is running. Now to see the list of running containers, what command do we use?
Docker PS.
Docker PS, right? So when I say Docker PS, I will see that my Ubuntu container is not running. Okay. Now to list all the containers, including running and stopped, what command do we use?
PSI.
Docker PSA.
Docker.
PS
A.
Hyphen A.
Hyphen A.
Right. Now here I see that my Ubuntu container is here in the stopped state, right? The moment I ran an Ubuntu container, it did run the Ubuntu container, but immediately stopped it or exited it. Now, why is that? Unlike virtual machines, containers are not meant to host an operating system. they are just a moment, my system. Okay. Okay, so I was telling, unlike virtual machine, containers are not meant to host an operating system. Containers are meant to run a specific task or process, such as hosting an instance of web server or application server or database server, or simply carry some kind of a computation or analysis task. Once the task is completed, the container exits immediately. Okay, and container only lives as long as the process inside it is alive. So if the web service inside the container is stopped or crashed for some reason, the container will exit. That is why when you run a container from Ubuntu image, it stops immediately, because Ubuntu is just an image of an operating system that is used as base image for other application. When you want to create some of your application images, you can use some of the operating system images. In Ubuntu, there is no process or application running by default. That's why it exits immediately. Okay, got it? So when we ran the Nginx image and we exited the Nginx process, so you remember when we did a control C, in fact, our Nginx container exited because the process inside it was not alive. Okay. Fine. So now coming back to few more commands. If the image isn't running any of the services, as in the case of operating systems like Ubuntu, so we can instruct Docker to run a process with the Docker run command. So how can we do that? So let's say I run the Ubuntu container once again, but this time I'm instructing Docker Ubuntu container to sleep for 5 seconds. So sleep is a process which I'm telling Ubuntu to run when it starts. Okay, so in this case, what happens is when the container starts, it runs the sleep command and goes into sleep for 5 seconds. Post the sleep command is executed for 5 seconds, the container will again get stopped. Now to notice it here, let's sleep the Ubuntu container for 20 seconds. Here I'm executing sleep command for 20 seconds. And you will notice that after 20 seconds, it will die immediately. Okay, you see that the container has died immediately. Okay, now one more thing we can do. We can append the bash command. Bash as a process we can run in Ubuntu and run it in interactive terminal. So to auto log into container while running it, we can say docker run -it Ubuntu bash. Now this command is used to auto log into container while running it. So I'm going to execute the same command and I'm saying docker run Ubuntu and IT is for interactive terminal. In detail, we are going to talk about IT as well. Okay, so when I see this, when I execute this command, docker run -it bash, you see that here I'm in root @PC, and now I'm inside my container. This is my container ID. Okay, so within our container, we can run some of the commands and see if that is working perfectly fine or not. So run some commands within your container. So you have a Red Hat on your Docker host, correct? So let's check the operating system of the container. So to check the operating system, we can type cat slash etc slash star dot release. Okay, so it says Ubuntu 20.0 LTS. Do you also get that?
Yes.
Yes.
Okay. Now to exit from the container, we can type the exit command. And now when we see the list of containers, we get to see nothing over here. Okay. Now, in fact, here if I type cat slash etc slash release, I will see that I'm running Ubuntu 18 on my Docker host. Okay.
Sir, while executing this cat slash etc slash release, I'm getting no file, no such file or directory.
Okay. Are you putting a star
Yeah, I'm
between?
putting a star.
Okay. That's strange. Can you share the command which you're executing?
Yeah, just one sec.
Just checking this. Okay, you have to put a space after the cat.
Okay. Oh yeah, now it's working.
Okay, great. So now I'm going to run an Nginx container once again. So let's see this. So to run Nginx container, I type the command docker run Nginx. Okay. Now again, as you can see, my Nginx is running in the foreground. So when you run a container with docker run command, Docker actually runs in the foreground or in the attached mode, meaning you will be attached to the console or the standard out of the container, and you will see the output of the web service on your screen. You won't be able to do anything here. Let's say I'm hitting enter and just typing the command, nothing happens over here. Okay, so now to stop it, we can type Control C. Okay, so Control C is what we can type to stop the container. And when we hit Control C, the application hosted on the container exits, and you get back to the prompt. Now, another option here is to run Docker on the background in the detached mode. So how do we do that? So we can type docker run -d. So -d is for the detached mode. So let me run the Nginx container in the detached mode. So if I type it like this, you see I'm not attached to the container console now. And now if I want to see the running container, I type the docker ps command once again. So let me type that here. I type docker ps and I see my nginx container is running. Okay, so -d is a useful option for the docker run command. Okay, so now next, if I want to, is it done? The container is running on the detached mode.
Yes.
Okay, great. So now if I want to see the logs and attach it to the screen, what do I do? So for that, I can again use docker attach and then the container ID. So what's my container ID here? Okay, so I type docker attach and this is my container ID. So I can type this as a command, docker attach and then the container ID. In this case, I am now attached to the Nginx console, Nginx container console or terminal. Now to again come back to screen, I'll have to hit Control C. Now in this case also my container exits. Okay. To um, attach it to console in the correct way, we are going to see how do we attach to console and execute some of the commands. Clear? So now let's run the nginx container once again. Okay, so this is an exercise which you can do now. So run a container from timer image. It prints the current time. And then you can exit from the container, run the same container in the detached mode, and then attach the container to see the output.
Sir, while trying for timer image, it says pull access denied for timer.
Yeah. That
It
is.
says unable to find timer.
Yeah, and we don't have any official timer image on the site also.
Yeah.
Oh, okay. I think they would have removed it. I'm trying to run it. Okay, pull access denied. I think they have removed it. So anyways, this you can skip for the moment. I'll see if I can get some other exercise. Okay. Now, in the previous session, in the previous slide, what we have seen is executing a command when we run the container, right? So I'm talking about when we executed this particular command. Okay. So when we wanted to sleep uh, our Ubuntu container for 20 seconds, we executed this command. But what if we would like to execute a command on a running container? So for that, I can use the docker exec command, which is docker execute command. So it executes the command in your running container. So let's say I run an Nginx container in the detached mode. Okay, so I run a container in the detached mode, which is my Nginx, and on this container I want to see the host files or the release file. Let's say I want to see. Okay. So I will first find out the container ID of this, and then I type docker exec, then my container ID. Okay, so docker exec, then my container ID, and then the command which I want to execute. So /etc/star.release only I'm typing to check the version of OS it is using. Okay, so no such file, it uses Debian. I got it. I can use /etc/hosts to see the host file within the container. Okay, so this is to execute a specific command in a running container, or in fact I can just type ls. So this listed the directory within my container. Okay. Okay, so now moving on. Now here we run a container which is already running for us, Nginx. Now, okay, so this is about deleting the container which we have already seen. So when we delete the image when the container is running, we notice that it fails to delete, right? So if I execute this command again, it is my docker rmi Nginx. I'm trying to delete the image. It does not allows me to delete because one container is already running with this image. Okay, so first we need to delete the container, then we need to delete the image, and now when we see, our image will get deleted. Okay, so now you can perform these exercises. Okay, so now if you want to take a break for 15 minutes, you can take a break. It's 11:50. We can resume at 11:30, and then spend about 10 minutes to execute this exercise, or else you can do it now and then take a break. Your choice, whatever suits you best.
We can take a break and then execute.
Yeah, you can do that. Means you have 25 minutes. Take
Okay.
a break first, or do this exercise, whatever your wish. Hello. Yeah. Is it done?
Yes, sir.
Okay. Fine. So now here we have few more exercises. I'll just share the URL to all of you. Okay. Now I've sent the URL in chat window. So all of you can open this URL. Now, once you open this URL, you can click on Start Scenario. Here you will get Start Scenario. Click on this. Is it done?
Yeah, it's just loading.
Okay.
Do we also have to make that directory?
No, you don't have to make it again. Okay. So if this is open, you get two things here. One is the terminal and second is the quiz portal. When you click on quiz portal, it will open up another page. Okay. So here you get the questions. So suppose this is the question, what is the version of Docker server engine running on the host? So in this, I can go and type Docker version. So that gives me 18.09.7. So I can make my selection over here. Okay. Similarly, you have a bunch of questions over here. So spend about 15-20 minutes on doing this exercise. Do let me know if you have any doubts. Or even if it is not opening, just let me know. We can have a look. I hope all of you are able to access and started this.
Yes, sir.
Yeah, okay, great. Is it done? Hello.
Yes, sir. It's done for me.
Yes, sir, it's done.
Okay, great. How about other people? Everyone done?
I'm left with 2 questions.
I am doing last 3 questions.
Okay, sure. We'll wait another 5 minutes.
It's done for me.
Is it done now?
Yes, it's done.
Fine. So now we'll get started with Docker run. We have just got into the overview of Docker run, but we've not talk about in detail of that. Now let's talk about Docker run. So in this, if I have to run Redis, we can simply run Docker run Redis command to run the Redis container. Now in this case, when I run this particular command, the latest version of the Redis gets downloaded. Okay, I'm downloading the latest version of Redis and I'm running the container with the latest version of the Redis image. But what if I want to run a Redis container with a specific version? So here I can specify docker run Redis :4.0. Okay, so if 4.0 is the version which I want to run for Redis, then I can specify with a :4.0. Okay, now this :4.0 is actually the tag of the Redis image. Okay, here in the first command, as you can see, the tag is the latest tag by default. If you do not specify a tag, it will always take the latest one. Okay. Now, if we specify docker run Redis 4.0, it will pull the 4.0 version of Redis and it will run the specific container. So as a user, how do we find the information about these versions and which one is the latest? So for this, we can open the Docker Hub and type Redis, and we can see the official tags which is available in any of the Docker images. So let's talk about Nginx. So here you can see latest tag. So when I just run docker run Nginx, this image will get downloaded. If I want any of the other previous version like 1.18, so I can type docker run Nginx :1.18.0. Similarly, if I look at Redis, I can see here different kinds of tags which are available here. So 6.0.6, which is also the latest tag. If I want any of the previous versions, I can simply put a colon and provide the tag over there. Okay. Now you have to follow the same approach, and let's try to run a different version, which is 5.0.9 for Redis. So if I have to run 5.0.9 for Redis, what will be the command? Docker run Redis, then colon 5.0.9. Now this is saying that it is running Redis 5.0.9. I already had it downloaded, so it's not. It did not take much time. But if you try to run this command, for you it will take time to download the image. Okay. Now you have to do one exercise again here, which is run Ubuntu 14.04 and print the release information. So how do you give a command while running the container? So for Ubuntu, we gave a sleep command, right? For that, we ran docker run Ubuntu, then sleep 5. Similarly, if you have to print the release information, you have to provide the command while running the Docker container itself. Okay. So just ping me in chat what will be the command for this. Is what will be the command for this. If I have to run Docker Ubuntu 14.04 and print the release information.
Sir, I think first we'll have to like write the Docker run command, and yeah, then the exec one, exec container ID and the command.
Okay, so Kartike sent a command which is correct here. So I'm just going to copy and paste it here like this. Now, when we wanted to run the sleep command in Ubuntu, we just ran docker run Ubuntu, then the sleep command. Similarly, if I have to print the release information, I am going to do this docker run. Now 14.04 is the image name. cat/etc/release is the command to print release information. Okay. So this by typing this command, I'm running Ubuntu 14.04 and printing the release information. Okay.
So when do we use that exec command?
Yeah, so exec command you use when you want to get inside, when you want to execute a specific command in the running container.
Okay.
Okay, so in this we had to run a container. While running itself, we wanted to print the release information. Okay, so now my Redis is running, let's say. Here I want to print the host information, let's say. Okay, so I type docker exec. I have to provide the container ID.
Okay, I've got it.
Okay, fine. So now let's look at the other things. So here I have a simple prompt application that when I run asks for my name. On entering my name, it prints a welcome message. So let's see this application. Okay. Now, okay, so I have this app.sh, right? So let me run this. Permission denied. Just a minute. So in this I have the required permission. So I'm going to run app.sh, which is a simple application which prompts me for to enter my name. Okay, So it says welcome and enter your name. When I enter my name, it prints a message, hello and welcome Prabhav. Okay. But when I Dockerize this simple prompt application, so when I run the Dockerized simple prompt application and I type this command, docker run Prabhav Agrawal / simple prompt. So when I run this, it does not ask me to enter my name. So let's see this. Now, where is this application? I'll show that to you. Where is this image? So here is the image, Prabhav Agrawal simple prompt. Okay, this is the image. In fact, you can also try running this image. Okay, so let me run this. I type this command, docker run, then Prabhav Agrawal / simple prompt. Okay, now when I run a Dockerized version of it, you see it did not even ask me for entering the name. It simply prints welcome, enter your name, and then hello and welcome. So it does not ask me to interactively interact with this terminal. So in that case, I can use interactive mode and turn on the interactive terminal. So the -i parameter is for interactive mode and -t stands for terminal. So with the combination of -i and -t, we are now attached to the terminal as well as in an interactive mode on the container. So let me try running this command with interactive terminal. Docker run -it. Now when I run the same command, you see I'm in the terminal and also having the interactive transaction over here. When I type this, somehow it prints hello and welcome Prabhav. I run this and I type a different thing here. It prints the same message. Okay, hello and welcome world. So this is about the using interactive terminal with Docker when you want to run or interact with your Docker containers as such. Okay, clear? So now let's look at another example. So now we are going to run a simple web application. Okay. Now remember this, we are running on the Docker host and we have installed Docker Engine. When we run the containerized web application, it runs and we are able to see the server is running. But how does my users access my application? So let's run this. Let's run this simple web application. Okay. So all of you can also try running this. I'm running Docker run Prabhav Agrawal simple web app. Okay. Now I save this simple web app and now here I see my application is running. It gives me a message that running on http://local 0.0.0:5000. But how do my users access my application? How do I access my application? Maybe using the IP address and port. So this is the IP address of my container, 172.17.0.2. Now, how do we get this particular IP address? I'm not run this in detached mode. So what I'm going to do now is I'm going to go to another terminal over here. and say docker ps. Now this is my simple web app. So I can do a docker inspect. I can use docker inspect command and find the IP address of my container. So the IP address of my container is 172.17.0.4. Let me try copying this. And
Sir, can you repeat the step? I lost connection.
yes, yeah, sure. So here we are running a simple web application by typing docker run Prabhav Agrawal / simple web app. This is my image.
Yeah.
Okay. Now, when I run this docker run command, it says my application is running. You see this here, running on
Yeah.
HTTP this.
Yes.
But how do I access my application, or how do my users access the applications? So one thing is I can access it using the IP address of my container. To identify the IP address of my container, what I did was I went to another terminal.
Yeah.
So this is my another terminal. I say here docker ps. Now when I execute this command, I get the container ID.
Yeah.
So here I can do a docker inspect. Inspect will basically tell details about my container. I'm going to inspect how my container is initialized.
Okay.
So I say docker inspect and the container ID. Okay. Now, once I run this docker inspect command, I get a lot of details which we will see later. But for now, I get the IP address, which is 172.17.0.4. So one thing is I can try copying this IP address and try accessing it in my browser. And here, what was the port number? It
5000.
was 5000, right? So let me try doing this, and I see it is not working here in my system, right? But when I go to my Docker host, so you might not be able to do this, but when I go to my Docker host and access it with GUI, and here when I open the web browser, I'm opening the Firefox browser here. Okay, so now in this I type the IP address, which was 172.17.4:5000. I get a welcome message. Okay, so basically my application is running over here within the Docker host. So what you can also do is when I run this application, you see my logs are coming that someone is accessing the application as well. Now what you can do is you can use curl command to see if this works. So I'll do a curl from my terminal. I say curl http:// and copy the IP address :5000. So here I get a welcome message as well. Okay, so that means within the Docker host, I'm able to access my application using the container IP address.
Yeah.
But but this is only the internal IP address. So from the Docker host, I'm able to access my application. But how do users access the application who are outside of this Docker host? So for our scenario, for your case, your Linux VM is on Amadeus data center, right? You're able to access within the Linux VM, but from your system, how do you access it? Or in my case, from my system, how do I access it? So we can access it using the Docker host IP address, which in my case, it is 192.168.0.106. So let me try accessing it here. So 192.168.0.106 and then 5000. So when I do this, in fact, now I'm not able to access my application, right? So to make this work outside my Docker host, I need to map the port. Okay. So map port from Docker host to Docker container. So here in this diagram, as you can see, I have my web application running on port 5000 and I'm mapping it with port 80 on my Docker host. So to do so, this is the command docker run -p 80:5000 and then the name of your image. So let's try doing this. Now I'm going to exit. I'm going to type a control C over here, but it does not allow me to do so. So I'm going to stop my container here. So I say docker stop and then my container ID. Okay. So it stopped my container. Now here what I need to provide is the port mapping. So let's say we want to run this in port 80, right? So I'm going to provide port 80, which is my host port colon my container port. Okay. Now I'm also going to run this in detached mode because I do not want the screen to get held up. So now you see my container is running. The container does not run because it says port 80 is already in use. So I'm going to make use of port 81. But for you, it might have worked because you don't have anything running on port 80. Okay, so when I run docker run -p 81:5000, I see that my container is running. Now, in my Docker host again, what I will do is I will inspect this container and find the IP address. Let's see if it is running or not within the Docker host. So I inspect this Docker inspect and I get the IP address as 03. Okay. So here I'm in my Docker host and I'm typing 172.17.03 5000 and I see this is running. Okay. Now, if I want to access this outside my Docker host, what IP should I use here? Considering this IP address and this IP address, which one should I use? If I want to access it in my web browser outside my Docker host.
VM's IP.
Yeah, so I'm going to use VM's IP, which is 106. But what port number should I use here?
80.
Yeah, 80 you can use. Now, since I've run it on 81, I'm going to use 81 over here. So now you see my application is perfectly working fine, even for the external users. Okay. So similarly, I can run any other container. As you can see here, I can run another container, which is MySQL, and I'm mapping port 3306 to 3306. The first one is host port, and the second one is container port. Clear? Is this clear? Port mapping?
Yes, it's clear.
Okay, fine. So now what you need to do is run an Nginx container and map it to port 8088. Okay. Now, just an information here, the default port which Nginx uses is port number 80. What will be the command to run this? Okay, so I see some commands in chat. Yeah, that's correct. Yeah. So I'm going to use here docker run -p 8088:80 and then nginx. If I have to run it in detached mode, I can type -d as well here. Okay. Now you need to run a MySQL container and map it to port 3306.
Sir, could you explain it to me, like 8088:80 and why not 80:80?
Okay, so it is always host port : container port.
Okay.
So I
So,
want to run it on 8088, so
okay,
which will be my host port. Okay,
okay,
so that's why 8088:80. Why :80? Because the default port which Nginx uses is 80.
okay,
Now, if you try giving a different port,
hmm,
let's say you run Nginx and do a port mapping of with -p 8088:8088. In
yeah,
that case, your container will run, but you will not be able to access it because
okay,
you are reaching out to a wrong port within the container.
okay.
Okay, so you have to run a MySQL container, map it to port 3306, and then log into MySQL container. One thing, default port of MySQL is 3306.
Above MySQL is getting exited.
Okay. Let me try this here. Okay, what does it say? Does it say port already in use?
No, it doesn't say this.
Okay.
I think for us it is not in use.
Okay, so MySQL is getting exited, right? Now, since
It says you
MySQL
have to
is,
initialize the password.
yes, since MySQL is getting exited, because you've not provided the password during the initialization of MySQL. So for me, let me just execute this command without the -d. Okay, so I say database is uninitialized and password option is not specified. Okay, so there is a concept of using environment variable. Now, while running the MySQL container, we can pass our password which we want to use using environment variable. So that's something which we're going to look at next. Now, let us start with a simple web application written in Python. Now, this piece of code is used to create a web application that displays a web page with a background color. If you look closely into the code, you will see a line that sets the background color as red. So here you see I'm setting the color equal to red. Now, this application just works fine. However, if I decide to change the color to blue, let's say, in future, then I need to change my application code. So that's not the correct approach of having this. So these kind of configuration, like the color or password in case of MySQL, it is best practice to move such information outside of the application code and into an environment variable. So here I am using an environment variable app_color. So the next time when I want to run my application, so I can set the environment variable called as app_color to the desired value of my choice. So let's see this here. Here, if I'm running this application, just using the shell command, I say this export app color equal to blue and then Python space app.py, name of my Python file. Okay, now let's see how do we pass environment variable in Docker. So now I have packaged the same into a Docker image and I'm using the same variable here, app_color. Now, once our application gets packaged into a Docker image, it would then run it within Docker run command followed by the name of the image. Right. So this way, by using the -e or -e option, we can specify the app color over here. So in this case, I'm going to specify the port values also here so that I can access it outside. Okay. Let me run this. Okay, so here I'm typing a command which is okay. So I'm going to run it in 82, port number 82, and in detached mode, the name of my image is app simple web app -color, and I have to also set the environment variable. -e app underscore color equal to blue. Let's say I set this. So I'm going to just paste this in the chat as well. Or if you want to run it on your own, you can also do that. Let me paste it in chat first. Okay, so docker run -p82 -e for environment variable, which is blue, -d for detached mode, and then the name of my image. Okay, so now I'm running this and I've pasted in chat window also. Now, similar to that, I can run multiple instances of my application and set the different colors, which is green or pink. Now I'll start some more instances of this and say it as green and setting it to 83. Then I say it as pink and then 84. I'll spin off one more and set the color to red and saying it as 85. Okay, so I have 4 containers running for my web application. For each one of it, the environment variable or the app color is set to a different color here. Now let me try accessing this. So it is 82, starting from 82. I'm getting this as blue, and then 83 is green, 84 pink, 85 as red. Okay, so now this becomes very simple, and we are actually giving user to input its own environment variable based on the value which he wants to choose. Similarly, when you're dealing with some containers which uses passwords and all, then you pass the password as an environment variable. So is this clear? The usage of environment variable?
Yes.
Okay, so now we have looked at a simple web application. The exercise here is now create a MySQL container using environment variable. Log into MySQL container and create a database. How do we get the environment variable which has to be used? So if I type MySQL, usually on the official images, you have the environment variables also listed. So these are the environment variables. So you see this MySQL root password. Okay, so here, as you can see, I can just specify docker run then MySQL -e root password file it is, but you can use only the password, not the file. And here you can directly specify the password which you want to use. Clear? On the Docker images itself, these kind of information is provided.
Sir, so in the documentation that has been shown in the site, so that will create a new MySQL instance or a container in our VM, but so that won't help us to connect with the MySQL which we already have it installed in our Windows, right?
Yeah, in your Windows you don't have to do it.
Okay.
So to log into MySQL, what you can do is you can use MySQL -u and -p. So you can specify U is for user, root is for root is the user, -p you have to provide the value. So if I do this, it considers that my MySQL is running on localhost :3306. So if I provide a password here, if I provide a correct password here, I don't remember my MySQL password. So yeah, once you provide the correct password, you will be able to log into MySQL.
So like this command is to means access the MySQL which is in our local host, and the Docker run would create a new container and have MySQL there, right?
Yeah. So when you will run the Docker um, run command, if you do a port mapping to localhost 3306, then you can type this itself, or else you can type -h for host information, and then you can provide the full MySQL address. Okay, or else simply what you can do is
So now what we have to execute, like only Docker run the MySQL.
okay, just a minute, I'll tell you.
Yeah.
So let me run this MySQL environment variable. So just send it on chat. What command do you use here?
Yeah, 1 minute. I haven't written it.
Okay, so let me run it anyways. Docker run. Okay.
Yeah, I sent.
Okay. Yeah. Got it. So Docker. You're giving us my secret -pw, right?
Yeah.
And then MySQL. Okay. So I've provided it twice. So I'm going to keep the password as also root. Okay. Just a moment. So typing it docker run -e, which is my root. Password is root -d, and then okay. So this looks okay, and now I want to do a port mapping as well here. Okay. So let me map it to one port. So for me it is
-p -p 3306 then :3306.
Yeah, for me 3306 is occupied. So I'm going to use 3307. Okay, now I'll just run this particular command. Is it in yeah, it's in detached mode also. Now if I see docker ps, I see that it is running. So one simple thing which I can do to connect is open MySQL Workbench in my Windows host, in my Windows system. Okay, since I've mapped it to a different port, I can use Workbench. If it was not mapped to the this particular port 3307, then what I had to do was I will select docker inspect and see the container IP, which will be 172.17.02. So in this case, what I need to do is, okay, I will type MySQL -u root -p and -h I need to provide the host by MySQL IP address.
Sir, so in my case, I have mapped it to 3306 only, so I don't have to provide the host information.
Yeah, you don't have to provide the host information in that case. And then I type my password. You see, I'm into the MySQL. Okay. Now, yeah.
Okay, so I'll have to write sudo mysql and then go through it because it says for me command not found.
Okay. When
Sir,
you say
for me,
command
even
not
with
found,
sudo, it says command not found.
Yeah,
okay.
same.
When you say command not found, that means MySQL is not installed in your MySQL CLI is not installed in your system.
Okay.
So what you can do is, this is my workbench, which is on my Windows machine, right?
Yeah.
So here I can click on new connection and I say docker MySQL. I'm giving a name. Now here, what IP should I provide?
Linux VMs IP.
Linux VM IP, right? 106. And I have it on 3307, so I'm going to provide that. And to test my connection, I can click here and provide the password of it. And it says connection successful. So I can click OK. And you see this connection is created for me. Okay. So I can just double click on it. This will start my connection. And here I can execute some command, create database test, something like this. I can execute. So this will create a test database for me. Okay. So
while connecting from Workbench, I am getting some error. Authentication plugin shashing SHA-2 password cannot be loaded.
Can you send the error in chat?
Yeah.
Yeah, even I'm getting the same error. Failed to connect. Authentication catching SHA-2 password cannot be loaded.
Okay, let's see that. Okay, can anyone of you share the screen? We will have a look.
Oh, should I share my screen?
Yeah.
Okay, so yeah. Is my screen visible?
Yes, yeah. SHA-2 password cannot be loaded. and click OK here. When you click on test connection, you're getting this, right?
Yeah.
Okay. Show me the Docker command which you executed.
Yeah. Is it visible, sir?
Yeah. So Docker command.
Just one sec. For the MySQL one, right?
Yeah, I can see that.
Okay, I put yeah. The sudo docker on this one.
Yeah. Okay. So MySQL root password, you have given root and then -d MySQL. Okay. Now here also you're typing root as the password, right?
Yeah.
This kind of strange. It should work ideally. So let's do one thing. Let's log in using the CLI itself. 1 second, I'll tell the command for Red Hat. Okay, so type yum install MySQL.
I'll have to type sudo.
Yeah, sudo.
Install
MySQL. So we are only installing the MySQL client, not the server.
Okay.
Here. Okay. Now here you can type MySQL -u root -p. Enter the password.
Cannot connect to local MySQL
MySQL socket. Okay, so every one of you are getting this error.
Yes, I'm getting this.
Okay.
Yes, sir.
Okay. Each one of you are getting this. Okay.
Sir, I am not getting the error. It's asking for the password.
Okay. Just a minute. I need to look at this. What is the error? Okay, is your MySQL running? Just check once. Docker PS.
Just yeah, its status is up.
Status is on. And okay, do a Docker inspect and then the container ID. Okay, it is 0.2. Now type the host information also while running the MySQL command -h, then the IP. Yeah, before you space.
And this one, this IP address,
Yeah,
right?
this IP address.
Same.
Okay.
But I guess this time the error was different. The error which was
Yeah.
shown connecting.
Mhm. Okay. I think we can try deleting and recreating the container once. Authentication.
Sir, the default port for MySQL, is it 3306 or 33060?
3306. Okay. Arpit, can you delete the container? Okay. Now talking about deleting the container. So here the MySQL container is running, correct? So try removing that Docker RM.
Like so.
Okay. Yeah. Docker RM and then the container ID. So when you type this on a running container, it gives you an error. You cannot remove a running container. So
-f.
Yeah. So to do that, you can add a -f over there. Okay. RM hyphen. Okay. So this stops your uh, running container or removes your running container. Okay. Try.
Like the first one, the sudo docker run MySQL command, I'll write that.
Yes, in fact, I can share the command if you want.
This one?
Yeah. So
Run
sudo docker run 3306 -e. So remove an extra space which is there for -e. Okay. MySQL root password root -d MySQL. Yeah.
Oh, sorry. This was deleted, right? Yeah.
Yeah. Okay. Okay. Now try.
In the host one, right?
Yeah, I think it will be 0.2 itself. Try that. -u.
No.
Okay. Search file or directory. Get into sudo and then execute this command.
Sudo su and then I'll execute
Yeah.
the command. The same command, MySQL.
Yeah. Okay. I'm also this is more related to MySQL error. I'm just checking this. No.
No.
Okay. Okay, do one thing. Get inside the container. So exit from the sudo. Run the docker ps.
Have to write sudo, yeah.
Okay, this is the container ID, right? Now, docker exec. Docker exec hyphen it space container ID and then space bash. Okay, so we want to get inside the container. That's why we are executing this command. Now here type mysql -u root and then -p. Provide the root password here.
Okay. This one.
So from outside, you're not able to connect. I think that's more related to MySQL error. So to correct that, you can type the password again. If you want to correct it, I can tell you the command. Or else if you want to leave it like that, you can leave it. Okay. So our exercise here, you can create a database and then you can exit if you want to.
Sir, so now suppose, so instead of this host name 10.64.241, I'll have to give the host name of my container.
Instead of the host 10 dot.
This is my Linux VM's host name. So now if I have to connect, I'll have to give my like the container's IP address.
No, with container IP address, you won't be able to access it outside.
Okay.
Here you're already in MySQL. We got inside the container and then we are accessing the MySQL right now. Okay.
Yeah. So.
Yeah. So here you can create a. Yeah. Go ahead.
Yeah, no, like as you said, so what would be the command to like access without going into the container? I can access it only from my.
Okay. Just a minute. I'll put that in chat window. I'm just I'm anticipating that it should solve this issue, but we'll just give it a try. Not very sure about it. Okay, so yeah, sent it in chat. So we are going to use alter the user information.
Yeah.
Yeah.
I execute.
Yes, enter that. Okay. Now exit from the MySQL. Now you are in the container. Exit from the container as well. Okay. Now type
cannot connect to local.
Type the -h and the IP address.
Sir, I was able to connect using -h.
I think some issue with the MySQL password that you are providing over there. We can have a look at it later. Okay. Enter. Root.
Okay.
So now you're in MySQL. So the thing which we wanted to talk about is create a database here in your MySQL. Okay, I hope everyone was able to follow these steps. If not, I can just repeat it once again.
So please repeat it once.
Yeah, sure. So from where do I do that? Okay, Mahima, can you share your screen? Okay, so now here, okay, so this one is correct. The command is correct to provide the root password. Now, first, what we uh, try to do is connect directly using the MySQL. So for this, you can type the command MySQL space -u space root space -p. Okay, hit enter. Provide the password, which is root. Enter. Okay, when you provide password, you will not be able to see that here. Okay. So now we are not able to connect it. So what we will do next is we will inspect the MySQL and we will try to connect it using the IP address of our container. So inspect the container, Docker, that's Nginx. That's the Nginx container ID. Okay, Docker space PS. Okay, now you get the MySQL container ID. Now this is the IP address 172.17.05. Now here type the MySQL command. MySQL -u sorry -h, yeah, correct. Then the IP address space -u space root space -p. Okay, type root and enter. Okay, now if you're getting this issue, which is authentication plugin caching SSH2 password, then you can get inside the MySQL container. So to do so, you type this specific command, docker exec. I'm also sending it in the chat window. Docker exec space IT. Okay, container ID you need to replace with the MySQL container ID. Now you see that it's getting tough to remember the container ID, right? So instead of that, we can use the container name also. Next time, I'll just tell you how to use the container name. Okay. So now you're within the MySQL container. Here you have to type MySQL -u root -p. Enter. Password is root. Okay. So now you got into MySQL container. Then execute the command, alter command, which is sent in Teams. The above one. Yes. Enter. Okay, now you can exit, type exit. So when you type exit, you will get to the container. Basically, you're exiting from MySQL. Again, you have to type exit to get to the Docker host. Okay, now type the MySQL command. Just press the up arrow couple of times till you get the MySQL command. Yeah, down. Yes, this one. Enter. Root. Okay, so now you are able to get inside the MySQL container.
So
Yes, thank you.
in my case, whenever I try to use the MySQL, it says command not found with MySQL.
Okay, so in that case, you can install the MySQL software, which is yum install MySQL. Does it work? Okay. I'm going to share my screen and I'll tell you some of the problems with this type of a command. Okay, and after lunch, we are going to talk about how do we solve that. Sharing my screen now. So as you can see, I have created a MySQL container and I've created a test database. Okay. So now I want to stop the MySQL container, remove the MySQL container, and then launch another MySQL container and see if the database exists. Okay, so let's try doing it. Now, okay, I say Docker PS. Now, by doing Docker PS, I get the container ID. Okay, so I can type Docker rm-f, so that will stop and remove my container both. So I'm just typing this command. Now it removed my MySQL container. Now I want to run my MySQL container again with the same command. Now here you see docker run -p 3306 3307, and I'm providing root as the password again. Okay, but now I'll tell you one more thing. When you wanted to inspect and see the IP address of MySQL, it kind of become difficult for you, right? When you wanted to inspect. So instead of that, you can also provide a name to your MySQL container by providing name equal to MySQL, or any name you can give over here, -- name. Okay, so we are going to execute this now. And I see my MySQL is running. If I want to inspect my MySQL container, since I have provided a name, I'll just type the name of my container, which is MySQL. So as you can see, the IP address is 17.02. So here, if I go to MySQL -h, then 17.02 -u root -p, I'm providing root as the password also. So now I got inside the container, and if I type show databases, I'll see that the test database which I created does not exist. Okay. So the data which you are having within the container lives as long as your container is alive. When the container is stopped or removed, your data also gets deleted. Okay, so that's not the correct way of initializing a MySQL container, what we did before. So whenever we have this kind of container or application which stores, which creates data that we want to persist, so we have to use a volume along with that. Okay, how do we use volume? We are going to see after the lunch. Okay, clear? Okay, so now we can take a lunch break. It's 1:30 now. We can resume at 2:30. Okay, and one more thing. Do you want time for the PPT preparation?
Yes, sir.
Yes, sir.
Okay, so shall we have it around 4 to 4:30?
Yeah, sure.
Okay. So 4 to 4:30 you can take for the PPT preparation. Then 4:30, around 4:30 your SMEs will connect, or maybe sometime later as well. Okay. So 2:30 to 4 we will have again knowledge session on the Docker. I'll see if I can finish by 3:50 so you can get a break of 10 minutes as well. Okay.
Yes, sir.
Fine. So we resume at 2:30 now.
Thank you.
Yeah, thank you.